The third video lecture deals with finding hydrogen ion concentrations and hydroxide ion concentrations. We start with the fact that occasionally a highly polar water molecule, remember polar is asymmetrical, will have enough kinetic energy during a collision, remember from kinetics, to transfer a hydrogen ion to another water molecule. So an H2O molecule in water will hit another H2O molecule in a sample of water, forming H3O plus. So an H plus leaves one of the water molecules and attaches to the other. And then the original molecule has an hydroxide ion left behind. These are now considered to be in an aqueous solution. The ions in water. It's a reversible reaction. The H plus ions joined to a water molecule is known as a hydronium ion, H3O plus. So you now have three ions you have to know for the acid-base unit, H plus, OH minus, and H3O plus. This is called the autoionization of water. We simply write it as this. So the H plus ion and the H3O plus ion are considered to be the same thing. The autoionization of water occurs only to a very small extent. At 25 degrees Celsius, the H plus concentration and hydroxide ion concentration are each only 1 times 10 to the minus 7th moles per liter. Very, very, very small. This means since they each equal 1 times 10 to the minus 7th, that their concentrations are equal to each other. And this is then described as a neutral solution. So water will break apart into H pluses and OH minuses. According to Le Chatelier's principle, if you increase one ion, it will decrease the concentration of another, and also shifts the equilibrium to remove the stress. So in an acidic solution, we will increase the H plus ion concentration. At the same time, they get used up, the hydroxide ions get used up as they turn into water. A basic solution is one in which the H plus ion is less than the hydroxide ions. However, when multiplied together, the two concentrations have to equal 1 times 10 to the minus 14th. So here we see in a neutral solution, H plus equals OH minus. As we become more acidic, we increase the H plus ion concentration. We decrease the hydroxide ion concentration, but when multiplied together, the two numbers have to equal 1 times 10 to the minus 14th, the H plus ion concentration and the hydroxide ion concentration. So typical problems include if the H plus ion concentration is equal to 1 times 10 to the minus 6, the hydroxide ion concentration will equal 1 times 10 to the minus 8th. Again, when multiplied together, we add exponents so that it equals 1 times 10 to the minus 14th. And since there are more H pluses, this solution is considered to be acidic. If the H plus ion concentration is equal to 1 times 10 to the minus 12th, the hydroxide ion concentration is equal to 1 times 10 to the minus 2. This time there is much more hydroxide ion, and so the solution is basic. And last one, if the H plus ion concentration is equal to 1 times 10 to the minus 5, the hydroxide ion concentration equals 1 times 10 to the minus 9th. Since we have more hydroxide ions, the solution is acidic. And that is it for today's lesson. So have a great night.